Today I discuss about the question based on the property of SAS. First question, a line L is a perpendicular bisector of line AB. P is a point on the line L. L, that is the point P, so that P is the equidistance from the A and B. Equidistance means the same distance. So P is the point on the line so that P is the equidistance from A and B. Means the length of AP equals to the BP. So that is called the equidistance. So how to solve? Given that if you just perpendicular bisector means the term is the perpendicular bisector, means a line that is the line is the perpendicular bisector, means both the angle are right angle. And so in triangle PAC and triangle PBC, PAC and PBC. First of all, given AC equals to BC, angle PCA equals to angle PCB, because PC is perpendicular bisector of AB. PC is common, or we written that PC is equal to CP or PC. Side, angle, side. So the triangle PAC congruent to triangle PBC by S categories. S, A and S category. Then we say that AP equals to BP by CP. If the length of AP, not like this, if the length of AP equals to length of BP, we say that the P is the equidistance from the A and B. Next question, BP and DQ are perpendicular on AC, and such that BP equals to DQ and CP equals to AQ. Then prove so that triangle APB C congruent to CQD. So prove given BP perpendicular to AC, DQ perpendicular to AC, and BP equals to DQ and CP equals to AQ. So prove that Prove A P B congruent to triangle C Q D. So in triangle, you prove that congruent that the A B P and D C Q. So in triangle A B P and triangle C Q D. What is the given? Given that BP equals to DQ. Angle BPA equals to angle DQC equals to 90 degree. AC is straight line, then angle BPC plus angle BPA equals to 180 degree. Straight line angle. So angle BPA equals to 180 degree minus 90 degree barabar 90 degree. Similarly, DQC is equal to 90. Next, AP equals to CQ. AP equals to, written that AQ plus QP and QC or AP barabar AQ is also equals to the CP plus QP. CQ is equal to CP plus QP. So we written that AP is equal to CQ. So in triangle ABP is congruent to triangle CQD by SAS category. The next question is that in a right angle triangle ABC, right angle at B. To prove that the line segment joining the midpoint of the hypotenuse, means D is the midpoint, opposite vertex of the half of the object, means say that the BD is equal to half of AC. BD is equal to half of AC. So how to prove? First of all, given AD equals to DC, angle ABC is equal to 90. That is the given. But in that condition we cannot solve it, so in something we constructed. We construction BD reduce to E such as BD equals to DE, means the length of BD equals to D also. And join CE. Then we get the two triangles. So in triangle ADB and triangle EDC. Where AD equals to CD, BD equals to DE, angle ADB equals to angle CDE, vertically opposite angle. So two sides and including angle. Then what do we say? Triangle ABD congruent to triangle CDE by SAS. If the two triangles are the congruent, then what do you mean? We also said that AB equals to CE by CT and angle ABD equals to DEC by CT, corresponding part from the congruent triangle. So anyone says that why that angle and that angle ही only, ये एंगल और ये एंगल इक्वल क्यों? क्योंकि तो पैरेलल दिया नहीं है सर. तो देखो लास्ट डे वी डिस्कस अबाउट दैट द अपोजिट angle of the equal sides AD equals to CD. So the opposite of that side angle ABD equals to the DEC. Also we say that the alternate interior angle, then what? AB parallel to CE. Converse of the parallel theorem, parallel angles. If alternate angles are equal, so the both the lines are parallel. So next, if AB parallel to CF, then angle ABC plus angle BCE equals to 180 degree. Sum of co-interior angle of same side of transversal be 180. Then angle BEC is equal to 180 degree minus 90 degree. So angle BEC is equal to 90 degree. Next, in triangle ABC and BEC. In triangle ABC and triangle BCE. No, ABC. So we written that ECB. AB equals to CE. Above proved. AB बराबर C by CPCT. Angle ABC equals to angle ECB बराबर 90 डिग्री. ABC is equal to and BC is common. So triangle ABC congruent to triangle ABC means ECB by SAS property. Then we say that AC equals to BE by CPCT. We have written that AC is equal to B. AC is equal to BE to BD because BD equals to DE by constructions. So where BD is equal to half of AC. Hence proved. Next question is that a line segment joining the midpoint M and N of a parallel side AB and DC respectively. ABCD is a trapeze. Trapeze means what? Trapeze means such type of the closed figure which one pair will be the only parallel, not equal. Only one pair where the AB and CD are the parallel but not equal. Where the M and N, the 2 points, are the midpoints of AB and DC, but both are the perpendicular to each other. Such type of the figure is drawn where the MN is perpendicular to AB and MN is perpendicular to DC. So prove that AD is equal to BC. So how to prove that? So in a triangle chapters, but we have not have any type of that triangle, so we just construct. So first of all, given that DN equals to NC, AM equals to MB, and angle DNM equals to angle NMA equals to 90 degree. or DNM. Also C and B equals to angle NMB is equal to 90 degree. Construction join AN and BN. So two triangles are formed. Then in triangle AMN and triangle AMN, so BMN. AM is equal to BM given because M is the midpoint. Angle NMA is equal to angle NMB is equal to 90 degree. And MN is common. So triangle AMN congruent to triangle BMN by SAS. Then we say that AN equals to BN by CT. We also say that angle 1 equals to angle 2 by CT because are equal. Next, so next in triangle ADN and triangle BCN. DN is equal to CN. N is the midpoint. Angle 4 equals to angle 3 because angle 4 plus angle 1 is equal to 90 and 4 बराबर 90 minus angle 1 or also angle 4 बराबर 90 minus angle 2 also will be because angle 1 is equal to angle 2. Angle 2 plus angle 3 is equal to also 90. So angle 3 is equal to 90 minus angle 2. So from 1 and 2 we say that angle 4 or angle 3 are equal. Also find that AN equals to BN above proved. So we say that the triangle ADN congruent to triangle BCN by SAS. So AD is equals to BC by CPCT. Thank you. So all the students do the exercise 7.1 question number 1, 2 and 6 from the NCERT.